Alright guys, today we're going to be talking about arc sine, arc cosine, and arc tangent. So just know that when you're talking about arc, alright, you're talking about the inverse. Okay, so we're talking about the inverse of sine, cosine, and tangent. So when you take arc, sine, cosine, or tangent, right, essentially what you're doing is you're returning an angular value, right? Normally, right, so we'll use sine as an example. If you take sine of an angle, well, you return a value. Well, if you take arc sine, you're going to be taking arc sine of a value, and you're going to return an angle, right? So you're working in reverse, right? So let's take a look at our first graph here. It's going to be sine, so we're going to start with sine first. And we want to take the inverse of this graph. Now, we run into a problem here because, right, if we go ahead and test to see if the inverse of this sine graph, right, is going to be a function, we'll find out that, well, it's not going to be because this fails the horizontal line test. Remember, you can perform a horizontal line test, right? And if it hits more than one point on the graph, that tells you that the inverse, okay, of that function, all right, is not going to be a function. So, in order to get around that, we need to restrict the domain here. And we're going to do that by restricting it from negative pi over 2 to pi over 2. So for example, our domain, okay, we're going to place a restriction on it, and we're going to have negative pi over 2 to pi over 2. Okay, and as our result here, our range naturally just becomes negative 1 to 1. Negative 1 to 1. Okay, so if I were to pull this little section off, right, so let's just go ahead and kind of make more of a visual here so you can see what's going on, right? I'm restricting it from negative pi over 2 to pi over 2. So essentially what we're talking about is this part right here. Right, so I'm just going to trace over it, this part right here. Right? So why don't we go ahead and create a new graph of this inverse, all right, and we'll do that right below here. So let's go ahead and just create a quick graph here. And this will be of the inverse. Now remember, you're taking the inverse here. So we know that our angular values are occurring on the x, right? Our values are occurring on the y. Well, since you're taking the inverse here, that's going to get switched. So now your angles are going to occur on the y. So we'll have pi over 2, negative pi over 2, right? And then we'll have 1, and then we'll have negative 1, right? And if we were to go ahead and graph this, we would get something like this, okay? Right, and our graph would look something like that, right? Now, let's rewrite the domain and range of this inverse. And why don't we go ahead and just, right, this is arc sine or inverse sine, right? So if we were to rewrite the domain and range for this new graph, right, well, all we have to do is look at our domain and range for our original. So our domain for our original, again, was negative pi over 2 to pi over 2. Our range was negative 1 to 1. However, we just took the inverse. So what do you think is going to happen to our domain and range? Right? Well, they're simply just going to flip, right? So now our range becomes our domain, and our domain becomes our range, right? So rewriting this, our domain now, okay, it just gets flipped. So now it's going to be from negative 1 to 1. Okay, our range now is going to be from negative pi over 2 to pi over 2. Okay? And for more of a visual, we can go ahead and represent this on the unit circle. So if we were to go ahead and just create the unit circle real quick, right, we get something like this. And we'll just divide it into the 4 quadrants. So our range, again, is going from negative pi over 2 to pi over 2. So how that looks on the unit circle is you have negative pi over 2 here and pi over 2. Okay, because again, you're starting at 0 and you're either going in this direction or this direction. Okay? So essentially, you're only talking about the first and fourth quadrant, right, when you're dealing with arc sine. Right, so the first and fourth quadrant. So as an example here, if you wanted to take arc sine, Let's just write this out up here. So arc sine, right, of, and we could say here of 1. What would this be? So again, you could go to your graph, right, and just draw out a visual. Well, look, that puts me at pi over 2, right? So arc sine of 1 is pi over 2. Well, do it in reverse. What is arc sine of negative 1? So again, let's try it over here. Negative 1. Oh, negative pi over 2. Okay, so that is arc sine, all right? Let's move on to arc cosine. All right, guys, so here is our next example. So we're moving on to arc cosine, and here is our graph of cosine. You're probably familiar with it. So we're going to run into the same issue here when we try to take arc cosine, because, again, if you perform the horizontal line test, you'll see that you hit multiple points, right, on this graph. So that tells us that the inverse of this function is not going to be a function. So we have to do the same thing here. We have to restrict the domain so that when we take the inverse, it will in fact be a function. Right? And we're going to do that the following way. We're going to restrict it. Okay, so our domain is going to be restricted from the following. From 0 to pi. And as our result here, our range will naturally be, right, well, it's going to be from negative 1 to 1. Okay? So again, for more of a visual here, right, if we're just kind of section this off here, right, we're going to have something that looks like this. Right, and just kind of retracing over what that's going to look like. Have something like that. So let's go ahead and create our graph now for inverse cosine. Okay, so creating our graph. So remember, you're taking the inverse here, so your x becomes your y and your y becomes your x. So, right, we have our angles on our x, our values on our y. That needs to switch when we're taking the inverse. So now our angles are going to be on our y, right, and our values are going to be on our x here. All right, and we're going to go ahead and just graph this guy now, and when we do that, we're going to get something that looks like the following. So I'm going to make my points here. All right, so we'll have something that looks like this. Okay? And again, we can rewrite the domain and range here, because now we're dealing with the inverse, so same thing as before, right, when we're dealing with arc sine. Well, we know that the domain and range are simply just going to flip, right, because it's the inverse. So we can write here our domain, range, right, so my domain here will be negative 1 to 1, okay, and then my range, right, will be 0 to pi. And for more of a visual, if you were to go ahead and draw this on the unit circle, right, well, we're going to have something that looks like this. Right, so here is going to be our unit circle. Right, so here is 0, pi over 2, pi, right, this is our range. Right, so essentially what you're talking about is you're only using the first and second quadrants, okay? So to give you a quick example here, right, if I wanted to take arc cosine or inverse cosine of, let's do 1 here, right, what is that going to be, right? Well, again, you could use your graph, right? Well, oh, it looks like I'm at 0 here, so this would be 0, right? You could do arc cosine, right, of negative 1. Well, where does that put me? And use your graph. So you go over negative 1. Oh, it looks like I'm at pi, right? Okay, so again, that is arc cosine. All right, let's go over the last one, which is going to be arc tangent. All right, guys, so here is our last example. And again, this is going to be arc tangent. So here we have our graph of tangent. And again, we run into the same problem when we try to take the inverse. Because again, if you perform the horizontal line test here, right, notice that it's going to hit our graph at multiple points. Meaning, again, that if we were to take the inverse of this function, right, it's not going to be a function. So in order to get around that, we need to restrict the domain, all right? And how we're going to do that is the following way. Now this is a little bit different than sine and cosine because we have vertical asymptotes here, okay? Meaning that the curve is approaching, but it's not actually going to that value, all right? So for example, our domain will be the following here. Now instead of using brackets, we're going to use parentheses because, right, we're approaching, all right, but we aren't actually on that point. Okay, so for example here, right, we're going to go from negative pi over 2. And again, I'm using parentheses because I have a vertical asymptote here, meaning, right, I can't be on negative pi over 2, right, because if it is, it's undefined at that point. So we're going right up to it. And then we'll have pi over 2. And again, we're going to use parentheses, not brackets here. Okay? All right. Our range here, okay, well, our range is simply just going to be all real numbers, okay? So to kind of give more of a visual here, what we're looking at is this part right here. Okay, so we're looking at this part right here. All right? Now, let's go ahead and make the inverse, okay, of this graph. So, starting below, right, we're going to have something like this. Now, we know that since we're taking the inverse here, right, well, the x becomes the y becomes the x. So again, my angles are now on my y, and my values are now on my x, okay? So let's just go ahead and do this. So I'm going to say here, I'll have pi over 4, pi over 2, negative pi over 4, negative pi over 2. Okay? And then we'll have our values here. So we'll have just 1, and we'll have negative 1. Now, let's go ahead and write our domain in range for our new inverse. So again, since the x became the y became the x, we're doing the same thing, right? These just get flipped. So our domain now becomes the following. Well, our domain here is going to be all real numbers. Our range, okay, is now going from negative pi over 2 to pi over 2. Okay, so again, you're using parentheses here. Now, notice we had vertical asymptotes here. Well, since we took the inverse, right, we're now going to have these horizontal asymptotes, and they're going to be at negative pi over 2 and pi over 2. Okay? And so if I go ahead now and just create my graph, right, we can kind of see what's going on here. So let's go ahead and do that. Let's move this guy out of the way. All right, we'll have something that looks like this. Okay. And so if we were to go ahead now and just create, all right, a unit circle to get more of a visual, right, so we'll just put it right here. Okay, again, we're going to break it down into our 4 quadrants. Well, look at our range here. We have pi over 2, negative pi over 2. Okay, so just like arc sine, we're only dealing with the first and the fourth quadrants. Okay, the first and fourth quadrants. So for example, if we were to take arc, let's do an example, arc tangent, then we'll just say 1 here. Well, what is that going to be? Well, again, you could go ahead and use your graph here. So at 1, well, it looks like we're at, pi over 4. Right? And we can go in the opposite way. We could say, right, arc tangent of, and we'll say negative 1 here. Well, where does that put me? Well, negative pi over 4. Okay? All right, so that is inverse sine, cosine, and tangent, right? Or in other words, arc, sine, cosine, and tangent. All right, and that is it.